Hello there. In this episode, I will go over the piecewise functions in exercise 2J. So starting with question 1, we're asked to find these certain values for different x's. So if we take a look at the first piece, this will be less than or equal to 0. Second piece is also going to come from the second piece, which is right on 0. Pi is positive, so it's going to come from the piece that is greater than 0, and so will 99. So therefore, f of negative 9 will just be 1. F of 0 will also be 1, whereas f of pi will be minus 1, and f of 99 will also be minus 1. So in terms of sketch, it will look like this. We have a straight line all the way to 0, which is at a height of 1. And this will be also including the endpoint, so we are going to draw a closed dot to represent the inclusion. And then it's going to skip over down to negative 1 and continue on with its path. And lastly, the domain in this case is we combine these two arguments here. So it spans across all real numbers. So that means domain is all real numbers. And the range, as you can tell from the graph, it only takes on two values. So you can either write down something like this, y such that y equals to 1 or 2. Or you can simply just write down, like y equals 1 or 2. So you don't have to really write it down in set builder notation. All right, question 2. So similar process. F of negative 4 is going to come from the second piece. F of 0 also comes from the second piece. And f of 1 is going to come from the top piece. So if we evaluate, we have f of negative 4 equals minus 4 all squared, which is positive 16. F of 0 will be just 0 squared, which is 0. And f of 1 will be 4 minus 1 squared, which gives us 3. In terms of the graph, it looks a bit different than the one that we saw last time. It's not a stepwise function because this is taking on a parabola on the left-hand side. So it will be useful if you know what the parabola looks like. So if this was defined for the whole function, it might look something like this. But I'm going to chop it down so that I only have the left-hand side. So I need to get rid of this side here. That means I'm going to go from the left-hand side, and then I need to stop at 0. And I'm going to include 0 because the inequality has it equal to 0. And then for the top piece there, when x is greater than 0, we evaluate the endpoint first of all. So actually for this piece here, 4 minus 0 squared gives us 4. So we know that it's going to start at 4. However, it doesn't include 4. So we still need to find out what the endpoint is for us to actually carry on drawing that line or drawing that curve. So 4 minus x squared is going to look something like this. Because we have f of 1 equals to 3. So therefore we know that it passes through 1, 3. I know I didn't do 2, but 2 should be right at the x-intercept because 4 minus 2 squared. 4 minus 2 squared is going to give us that 0. And then f of 3 is going to be negative 5, so I could have made this a bit better looking. So this will be exactly negative 5, so I could actually just join these 3 dots. So that would be a much more accurate sketch. So that's what the curve looks like. The domain and range. So if we look at the curve and also by the pieces that we give in, again, the domain will be spread across all real numbers because we have covered less than or equal to 0 as well as greater than 0. Whereas if you look at the range, okay, from this part here, it covers everything. So the left piece covers everything that is above 0, above or equal to 0. Let me draw the... So for the left piece, we have all these as the range, right? Whereas for the right piece, we have this to be our range. So if you take the union of those two lines, it's really hard to see the blue and the green line, but if you take the union of those two, they are going to spread across the entire y-axis. Therefore, this has a range of all real numbers. Question 3. So just like before, f of -1 is come from the second piece. So it's f of 0. F of a is going to come from the top piece. So putting these numbers in, we get -4, -1, and 3. So you can actually use some of these points to help us sketch. We can use -1 and 0. -1 is going to go down to -4. Actually, I forgot to label the axes, but you can treat all of these as increments of 1. So that applies to other questions before as well. And we have f of 0 to be -1, so I have these 2 points. And I know this is just a straight line, so 3x minus 1. So I can confidently just join them up by a straight line. Oops. Actually, it wasn't that bad, but let's do a little bit better. Again, we're going to stop at 0, so this is a closed dot. And then, when this is actually 0, we actually have it beginning at 1. So we start off with an open dot at 1, and then we're going to carry on with the square root function. I know square root goes to like 1, 4, 9, 16, so I can just connect it like that. You can also just take some of these x's, 1, 2, 3, 4, and plug in a few of them. I just plug in the perfect squares, 1 and 4, because I know they're gonna give me numbers that are exactly integer. And just like before, the domain covers all the real numbers. This time the range has a gap, so we have everything. We have everything that is less than or equal to -1. And then we have things that are strictly greater than 1, starting from the positive piece. Four. So this comes from the second piece. The next one comes from the second piece as well. Third one comes from here. So 3 of these pieces actually come from the second piece. Be careful, if you look at the pieces here, the top one is actually the one to the left. So you have the minus, and then you have the greater than or equal to on the second piece. Whereas in the questions we've seen before, it's the greater than piece that comes on the top, and then the less than or equal to piece on the bottom. So just be a bit watchful on that. In any case, f of minus 1 will be 0. F of minus 4. Oh, actually, that's the wrong piece. I got to be mindful too. So f, oh, I forgot f of 0. Oh, no. Then I'm right. This is the second piece. This is the third piece. Let's do f of 0 first. This will be 0 plus 1, which is 1. Then f of negative 4. Now, if I actually plug in the second piece, I will get a negative square root. So I know I did something wrong anyway. So this will give us the absolute value of minus 3, which is just positive 3. And f of 8, we go back to the second piece, which is 3. So I can take 3 of these values and plot them. So at negative 1, it's 0. At 0, it's 1. Okay, I'll be lazy and not label the entire axis. And negative 4 is going to give us 3. And f of 8 is 3, but I don't have it here, so it might be somewhere here, just for your reference sake. Now to graph the two pieces, we have some points here, and we know that the two pieces sort of they have a gap, they have a jump right at negative 1. So for the square root of x plus 1, so I'm looking at the lower piece. Let's do the other piece here. Let's do this piece. Okay. So I know that this piece is going to look like a V shape, but there's a plus 1, so that means it's going to be shifted 1 unit to the left. So it should look like this, right? So if I look, basically it's going to be this V shape here, and it's going to stop there. Right, the other piece is actually there, but because the domain says only less than or equal, only less than negative 1, so therefore it stops at this point. And also, I need to erase that because I want to make this very obvious. Okay, there's a gap here, since this does not equal to 0. And then for the other piece, the square root, so if I have f of negative 1, oh, it's a 0. Yeah, it was this point here. So this one is a little bit odd, because for the left piece, it ends up with an open dot on the absolute value side, but it closes. So technically it's open, but it's closes by the square root sign. So I just use these two different colors to represent what's going on. So here we have the purple curve. And then, this should trail up to over there. So even though we have an open dot for the left-hand side, the right-hand side actually closes the curve. So this is a continuous curve. And there's actually no gap. The domain, again, it's all real numbers. The range, in this case, it's all non-negative numbers, because the lowest point is where those two curves sort of intersect. Well, not sort of, exactly. Now I want to take a graph and break it down into different pieces. Here immediately I see this as 1, 2, 3 pieces. Okay, so let's just take a look at this. This is a straight line, right? So what I could do is to find 2 of these points. Let's use a different color. Maybe I'll use this point and this point here. So what I'm really doing is to sort of draw a triangle here. And with that, I have a height of 3. So this is 3. This is 1. So therefore the gradient must be 3 over 1. So I know the equation of curve will be 3x plus b plus something, right? So maybe I will just take one of the points. I'll just take this point. This point is minus 2, 4. We can use one of our formula. You can either plug in this point. So this will be 4 equals 3 minus 2 plus b. So that's telling us the y-intercept has to be 10. So for this left piece, this will be 3x plus 10. So we're done with that. Also, you could have used the more general formula, the y minus y naught equals m times x minus x naught. So in that case, you would just do y minus 4 equals 3 times x minus 2. And then we should have the same answer. Okay, let me simplify the right first. This is the same as this. So if I expand the bracket and move the 4 to the right, then I have this. Okay, they're the same. So that's the first piece. Second piece is easy. It's a flat line, so this is at y equals 4. And then we're going to do the same thing with the right piece here. So we will take 2 points. Let's take this, and let's take that again. Now, do you notice that this is symmetric to the one on the left? So we can go through the same process, but I can pretty much say that the gradient is probably going to be the same. Well, in the other sense. So I know this is going to be -3 because it's a reflection upon the y-axis. So technically speaking, I can write down that this must be, y equals -3x plus 10. But if you don't believe me, then go ahead and plug in this point, which is 2, 4, and then do the same thing. So if you pretend that you don't know what the y-intercept is, then just plug in the points that it passes through, which is 2, 4. And then you should easily see that the y-intercept is also at 10. Okay, so to write that it's piecewise function, we can say that this is f of x, but it comes in 3 pieces. The leftmost piece is 3x plus 10 when x is less than or equal to -2. Then the middle piece is just a constant function, and we will set this between 2 and +4 inclusive. And the right piece would just be -3x plus 10 for x greater than 4. Okay, notice that if I put the equal sign here, I don't put it down here, otherwise they will be repeated. Same thing here, because I have put down the less than or equal, the equal case here, I leave it out in this part there. You could also just put the equal sign down here instead, or put the equal sign down there instead. Just make sure that you have it in one case but not the other. Otherwise, it's no longer a function. And the last question is to rewrite it as piecewise. So the definition of absolute value function is as follows. Absolute value of x is defined to be the positive when this is greater than or equal to 0, and when it's negative x if it's less than 0. Or, just like the equal sign, you can also write it like this. So that means you can toss the negative argument to, the equal argument to the negative as well too. Either way is fine. I tend to stick with this. So here, for a, we can pretty much just write it as this. Is the positive of the argument when the inside is greater than or equal to 0, and it's negative of this when this part is 0. Usually we want to write it in terms of x, so we can go ahead and just simplify that, and this will be -4 over 2, which is -2. So I'm just solving for x alone. Here you don't have to really expand the bracket, but it's up to you. And if you see that in this case, this should be when x is less than -2. And for b, very similar. So we break it down into 2 cases. I could write down this first. Technically, I can skip this part and just go right into what the pieces are. It's positive of that if the argument is greater than or equal to 0. It's negative of the absolute Okay, don't change the plus 2 because plus 2 is not part of the absolute value when this is less than 0. So let's combine some terms. This will be when x is greater than or equal to negative 9 over 3, which is negative 3. And this will be plus 9 plus 2, so this becomes plus 11 altogether. And then we have when this is less than negative 3. Okay, so that's how we can write this into piecewise functions. And from that, we can use it to graph. That's really the reason why we want to do it this way. Okay, hope you learned something. See you in my next video.